STEM thinkers and doers. I'm Dorinda Reisenhufer, and I'm the Education Coordinator for the NASA Oklahoma Space Grant Consortium. You heard it right, NASA as the National Aeronautics and Space Administration. We are one of 52 NASA Space Grant Consortia. There's one in each of the 50 states, one in Puerto Rico, and one in D.C. Now, with each of these NASA Space Grant Consortiums, they are housed at a university within their state. Our state office is out of the Oklahoma State University, which is where I am right now, inside our STEM Engagement Center. The NASA Oklahoma Space Grant Consortium has a STEM Engagement Center, or SEC, where we do a lot of our education and programming, including professional development for educators and a year-long mentorship for pre-service educators known as Stellar. And not only are we here on the OSU campus, but we're also part of the College of Engineering, Architecture, and Technology, or SEAT. So what an incredible place for us to get to be, and what an incredible facility that OSU has provided us with to do our programming. So enough about all of that exciting information. Now let's move into the STEM part, or the demonstration portion of this presentation. Now today we're going to be looking at NASA's Artemis mission, and specifically how NASA is going to get us back to the moon. Do you guys know how we're going to get back to the moon? Well, on a rocket, of course. How else would we get there? So this first experiment that we're going to do, we're going to build what's called a fizz rocket. We're actually going to build several of them because today we're going to look at something specific, not just building a rocket, but something specific about a rocket that makes it go. I wonder what that could be. Well, are you ready to find out with me? Let's find out. Okay, so the first thing that you're going to need to do is gather some supplies. So the supplies, depending on how many fizz rockets you will be making to experiment with, you're going to need one interlocking film canister for each of those rockets that you're going to build. Now, an interlocking film canister, did you hear me say that? Now you'll notice there's also another film canister that is black with a gray lid, and that lid goes over the outside of the canister. That will not work for this experiment. You must have an interlocking film canister. So for this, you can see how it's got those nodules on the inside of it, which allow it to lock on the inside. And that's going to be very important when we get to our experimentation portion of this experiment. So you'll need one of those interlocking film canisters per rocket you're going to make. Now, how do you get those interlocking film canisters? Well, maybe you're really lucky and you have somebody around you who uses Fiji film, and if they do, if they use a regular camera that still uses film, I know not many people do, but there are those, it's coming back. And so if you know someone, those film canisters typically are interlocking film canisters. Now, you can also order them from Steve Spangler Science. You can go on Amazon. Now, if you're going to go on Amazon, pay attention to the reviews and see if they say these work well for fizz rockets or not. Not all interlocking film canisters are created equal. So and I think Educational Innovations may have them as well. So those are some great places to get started for looking for those interlocking film canisters. The next thing that you're going to need is you're going to need a variety of items to create fuel. Oh, fuel. Maybe that's what we're talking about today. Well, I've got some different items up here. I've got water, just regular room temperature water. I have Diet Coke, Sprite, Coke, and I also have cold water that just came out of the refrigerator. Some other things that I'm going to need I'm going to need note cards so that I can make my nose cone and fins for my rocket. I'm also going to need some scissors and some tape. And it doesn't really matter what tape you use. We're going to use Scotch tape for today, so whatever works with that. You're also going to need some Alka-Seltzer tablets. And it doesn't have to be the name brand Alka-Seltzer, and ours aren't. It can be an off-brand. Usually that's a lot cheaper. Now, I will tell you, students out there, this is considered medicine. And since it's considered medicine, a parent will need to purchase this for you and handle it for you. Teachers, if you're going to do this with your classroom, I'd be happy to share with you. You can shoot me an email, and I'll share with you safe ways to do this with your classroom where you can do this with all the students, but just making sure that there's no way that they can ingest any of the medicine in that process. So today, how we have this set up is just more for families experimenting at home, but this most certainly can be done very similarly in the classroom. Okay, so the first thing I'm going to need to do is I'm going to make my nose cone. Now, I already have nose cones pre-made here. As you can imagine, we do this experiment a lot here at the STEM Engagement Center. But I'm going to go ahead and I'm going to fold my one piece of note card in half. And then I'm going to cut out a circle. Now, I could use something as a circle pattern if I wanted to. It doesn't have to be an exact circle. I mean, you're going to see just how scientifically exact and accurate my circle is. Okay, so yeah, my circles are just a little sad, aren't they? But they're close enough for what we're going to do. This will work. Now, the next thing you're going to do is you're going to want to cut a pie piece out of one of those. So we're just going to take and cut a pie piece out of one. And so it kind of looks like a Pac-Man or a Pac-Woman. And I'm going to do that out of my second one so that I'd be able to use both of them. So now I have 2 nose cone pieces. Okay, you only need 1 per rocket, but I have 2. If I'm doing more than 1, that shows you how you can get more than 1 out. Now, this part, I'm only going to get 1 set of fins out. So it takes 1 full note card per fin set, unless you're making smaller fins. But for how I'm making them, this is how we're going to do it. So first, I'm going to take my note card and I'm going to fold it like a taco. There we go. And that folds it in half 1 time. And then I'm going to fold it in half 1 more time. And honestly, it doesn't matter if you fold burrito or taco first. Either way works. But you're going to fold it in half 1 time. And you're going to fold it in half a second time. So you're going to have it look just like this, like a small rectangle. So what we're going to do is we're going to open that up, and now we're going to cut those rectangles out. And you can actually do numerous note cards at a time when cutting this portion out. Teachers, you could also use a paper cutter to make this go a little bit faster too in your classroom if you were prepping this beforehand for your students. Okay, so now you have nose cones and you have fins. All right, so I'm going to set these to the side because I have pre-cut ones that somebody so nicely actually cut very nicely out of a pattern for me. So the first thing I'm going to do is I'm going to take a nose cone for each of my rockets. So I've got 1 nose cone, and let's see, 2, because I'm going to do 4 rockets with you today. 3, and there is my 4th. Okay, so to make these into nose cones, it's really, really simple. I'm going to take the corners of my Pac-Man, so I've got my little Pac-Man, and see how, let's see, I'm going to put it on my shirt sleeve so you can see that. If you'll see how it's got the corners on either side, and I am going to just rotate it like that. So that makes a really nice nose cone. And sometimes when I would do this with students, they tell me it looks like a hat. Well, maybe kind of. So once I've got that together, I'm just going to tape it like so. So your nose cone is now going to look just like this. Okay? And I'm going to do that for each of my rockets that I need a nose cone for. Well, each of the rockets that I'm building. So I've got, here's my second one. And then for my third, I'm going to put my fingers on the corner. And it doesn't matter if your note cards are lined or not lined. You can also use construction paper, printer paper, scrap paper you have laying at the house. There are a lot of possibilities for this experiment as to what materials you use to create your nose cone and fins. Now I've got 3, so I've got to make 1 more, and so that I've got my 4th. Excellent. Okay, so now we have 4 nose cones. So I'm going to take each of these nose cones, and each nose cone is going to get 2 more pieces of tape. So I know that circles don't have sides, okay? But just for this, bear with me, because I'm going to say sides when I'm talking about this circle. So I'm going to take and I'm going to put my tape on one portion of my circle. Now I'm going to go to the opposite side as to where my tape is, and I'm going to put my second piece of tape. So I now have 2 pieces of tape hanging off. So 1, 2, and the sticky side is going down. and I'm going to stick it on my film canister. Now, I forgot a really important step because I already had mine that way. What I usually do is when I take off my lid, I have everyone who's making the film canister with me. We all take our lids off at the same time. We stick the open side facing up, and then I say, okay, now you're going to take the open side and stick it down and stick it on your table. So the closed side should be on your table. And I've done that with all 4 of mine. It's a really simple trick to make sure no one does this part wrong. Because if they do this part wrong, they can't get their fuel in the rocket. Oh, I'm giving away more secrets, aren't I? Okay, so let's go ahead and get this nose cone on one of our body tubes. So our film canister now has one of those nose cones on. And all I did was I took those 2 pieces of tape and used those to stick it to that top. And remember, the open side is still open. Only the closed side got the nose cone. So now let's do that 3 more times. So 1 piece of tape. And then I'm going to go to the opposite side and my 2nd piece of tape. Now you'll notice I'm using really small pieces of tape. And I want to make sure that as I do that I am not covering up the bottom of my film canister, the bottom of my rocket, because that's going to be really important when we go to try to put fuel in it and get it to launch. I've got to do this 2 more times, so 2 more pieces of tape. 1, 2, and we'll stick that on the closed side of the film canister or our body tube of our rocket. And then I will put 1 more piece on this last one and a 2nd piece. So now I've got 4 rockets that all have nose cones. So the next step is we've got to do our fins. So for my first rocket, I'm going to take 4 fins. So remember when we cut it out of the note card. And you'll notice my note cards aren't perfect, okay? So the ones that I've got right here, somebody cut them out really, really well. Mine weren't perfect and it still works. It'll be just fine. So you're going to take all 4 of them and put them all together in a stack. So I've got all 4 in a stack. And then I'm going to just bend 1 inch, just a very small amount. Maybe a 1/4 of an inch, maybe. And you could do more. You could even do a 1/2 inch. It wouldn't hurt it at all. But somewhere in between that. And so it kind of made like these little chairs on there. Can you see that? So now when I take apart all 4 of these, they're all going to have that little bend there. You guys see that? Okay, awesome. And I've got 2, 3, and 4. Okay, so we've got 4 fins. Now, once I've got my fins bent, I can now put them on my rocket. So I'm going to take a piece of tape, a small piece of tape, and where that bend is, I'm going to go to the inside and tape my sticky side to the inside. So now I've got sticky side facing out this way. And I will stick it on my rocket. Okay? And I'm just going to choose one side. Again, I know circles don't have sides, but I'm going to choose one side of my rocket to put it on. The next thing that I'm going to do is I'm going to take another piece of tape. I'm going to do the exact same thing, sticky side facing out. And I'm going to go to the opposite side of my rocket. And I'm going to put it on just like that. So now I've got 2 fins. Now, are they on perfect? No, but they're good enough for what we're doing. I love this experiment because you don't have to be exact. Now, if you're an educator and you're doing this with your students in the classroom, you may have exact places you want them to measure, exact sizes, and exact pattern because you want to limit those variables. For what we're doing, it won't change a whole lot for our particular experimentation today, but those are definitely adaptations that you can make depending on the level of your students you're working with. But for families out there, this works great. So on that 4th fin, I'm going to do 1 more. So my 3rd one, I had stuck in between on one side of the 2 fins. Now I'm going to go to the opposite side and stick it in between the other 2 fins. So now I have 4 fins which are fairly equidistant. Not perfect, but close. So I've got a few more rockets that I've got to get situated. So let's go ahead and I'm going to show that one more time, and then I'm actually going to leave fins off of my last two because I've got lots more to show you. And I think you guys will get this after one more time through. So I took my fins, all 4 fins together, and I bent them just a little bit. And now I can take them apart, and they're each going to have a bend in them, which gives me just a little flap that I can tape onto my rocket. It's going to make it easier to tape this rocket on. So now I've got the sticky side facing out. I'll put it on one side of my rocket. I'm going to do this another time where I'm going to go to the opposite side of my rocket. And then I'm going to go, oops. Pieces did not quite get the bend. Oh well, we'll just fix that really quick. Okay, so now I'm going to put another piece of tape on here, and I'm going to go halfway in between both of those fins. So now I have 3 fins on there, and now I have one side that's missing a fin. So let's get that on there. Perfect. And you'll notice I do not have any tape which is coming down over this opening. Extremely important. Okay, so now my rockets right here, they're just sitting here, aren't they? Right? You know what? Newton had a law of motion that tells us exactly this. And that is that an object at rest, it shouldn't remain at rest until an outside force acts upon it. So how are we going to add an outside force to our rocket? Wait a minute. Didn't I say fuel earlier? Let's think about that. Let's add some fuel. So I know something about some of the ingredients I have up here. And I know that when I put Alka-Seltzer in a liquid, and right now I've got it in this container of water, and I know that when I put an Alka-Seltzer inside that container of water, something is going to happen. So let's see what happens with that. Oh, can you see that? It is fizzing in there. And it's creating a reaction or a chemical reaction. And what's occurring is a gas is being created. Now, that gas is just going out into the air here at the STEM Engagement Center. But we're going to capture that gas so that it will create a reaction within our canister that will cause our rocket to go up. You guys excited? I know I am. So the first thing I'm going to want to do is I'm going to go ahead and get my Alka-Seltzer tablet ready. Now, if you are a student doing this, depending on your age, this may be something that your parents need to handle. That's a discussion you need to have with your parents beforehand, before you do this experiment. Parents, that's going to be up to you as to your comfort level. But just remember, make sure it's safe and that they're not going to be able to ingest this. So washing hands afterwards and making sure that any remnants of the Alka-Seltzer tablet are gone so no one can get a hold of them. So the next thing that we're going to do is we are going to set this Alka-Seltzer tablet to the side because first I want to put water. Now, for this one, I'm just going to use my room temperature water. And I'm going to fill it about half full. And I'm going to go ahead and use my whole tablet because why not? I've got a whole tablet. But you could experiment with that, right? You could use half a tablet. You could practice breaking it up, being it whole. We're just going to put ours in completely whole. And then we are going to put the lid on it. And we're going to see what happens. Oh my goodness! Did you see my rocket? Yeah! Now, did it go up very high? No, it didn't go up very high. So now I can begin to troubleshoot and figure out ways in which I can make it go up even higher. So for this next rocket, I think that I am going to use Coke. I'm going to see if that has any difference. So I'm going to fill up my rocket about half full with my liquid. And then I'm also going to use some more Alka-Seltzer. And I should have gotten this ready beforehand because now I have a container full of Coke. Well, I'm trying to wrangle out an Alka-Seltzer tablet. Okay, so I've got it ready. So this time, I'm going to see with Coke and half a tablet what happens. And where's my lid? Okay, you guys ready? Okay, Coke. And, oh my goodness, that went up higher. So I used less tablets. I used the same amount of liquid, but I also used a different liquid. And I really liked how that popped. Well, let's see what happens now with, I'm going to try, we'll do Sprite since it doesn't have caffeine and see the difference is. Okay, and I don't know that will make a difference. That's something you guys can figure out, and I'd love for you to send me emails or send information to our STEM Engagement Center to let us know what you learned in doing this experiment and what type of fuel caused your rocket to go the highest. So I'm going to put in about half full of the Sprite. Now that I've got the Sprite in there, I'm going to take and I'm going to break up my Alka-Seltzer tablet just a little bit. Okay, are we ready? Let's see if this gives us a faster reaction maybe. Oh no, it went so fast. I don't know that I may have missed the reaction. Oh, I still got some out of there, didn't I? Excellent, and that went even higher. So breaking up a full tablet and using Sprite went up even higher. And let's look at cold water. Now I'm going to use the same amount, exactly what I did with the room temperature water with our cold water and see what's different. So for that one, I used a whole tablet and I used a whole tablet and a half of a container of water. So we already did it with room temperature. This is cold water straight out of the refrigerator. So let's see if there's any difference. I'm going to stick that in there. I'm going to stick this on there. And let's see what happens. It's definitely taking a little bit longer for it to react, isn't it? I can see a little bit coming out of the bottom. We may have to redo that with one of the other. Oh, yes, it looks like it may have all leaked out. Okay, we're going to set that to the side. Now, notice I'm not getting over top of these rockets at all. I'm making sure to keep my distance so that if it does explode, it's not going to poke me in the eye. That's very, very important. So parents and teachers, make sure that you have a safe launch zone, kind of like I do right here, that you can really watch the behaviors of your students or children and make sure they're not going to get hurt because we don't want anyone to get hurt doing this. Okay, so now let's try one more time. Since we know this, it could just be the canister. Kind of a little odd that happened, but sometimes it happens. You will get canisters that are just duds when you try to do this experiment, and it's okay. So here again is the cold water, and I'm going to put a whole Alka-Seltzer tablet in there. I'm going to take the lid, I'm going to shake it just a little bit, and notice I'm out of the way. It looks like it's trying, oh, there it goes. So it did about the same. So maybe temperature doesn't matter. Maybe you get different results. I cannot wait to hear some of the ways in which you experimented with this experiment and created different reactions with your fuel. So depending on the rocket that NASA is using, that will decide what type of fuel they need for the rocket, how big the rocket is, what kind of reaction needs to occur to get them to the height that they need to get the astronauts where they are going. And not all rockets are created the same, right? Depending on where we're going, that rocket may need to have different abilities of power. As we're going beyond low Earth orbit, we're going to need more powerful rockets that take us even further. And so we're going to see some really different things occur within rocket engines. So I hope you had a really great time doing that experiment, but I've got one more way that you can take this another step. Now let's look at one more adaptation to this experiment that you could bring into your experimentation with rocket fuel for your Fizz rocket. One of the things that you can do is you can create a multi-stage rocket, because that's really how the rockets work with NASA. They're in stages, and there are a variety of reasons for that we won't go into today, but you can find all of that information on nasa.gov. But in order to do that, what you need to do is you are going to take a lid of one of the foam canisters, and you are going to glue that lid with the outside side of it to the outside closed part of your foam canister. So, for example, I would take some hot glue, get a lot of hot glue on there, get it really nice, And for those who are younger, you probably need a parent there working with a hot glue gun with you. And for your olders, just make sure that you're very careful and don't burn yourself in the process. But we glued the outside part to the top of another film canister. So what happens, now I have one that's already been drying, so we know it's not gonna fall off, but that lid, so the inside part is still facing out, just the outside part is glued to the other film canister. So now, when I go to put the film canisters together, I now essentially have two rockets. So I can now put, or two stages on my one rocket, I guess I should say. So now I'm going to encapsulate that in there, and then I am going to take another lid and put it on the outside there. Now before I do that, I'm going to want to figure out how much of the fuel I need to put in each of the stages, because I want this bottom part to go off first before the second part. So that's where your first experimentation comes in. You can figure out which of your reactions and which of your combinations of items, which fuel, created the slowest amount of reaction. And that slowest amount of reaction you'll want on the top and the fastest on the bottom. So essentially what will happen is this rocket will go up, and then hopefully what will happen as that reaction or that energy, that force stops, then the second one will go off by then. And that's a really neat thing to try at home. We don't have time to experiment with that with you on our show today, but I really hope you do get a chance to experiment with that and take it to the next level. Now let's wrap up a few things that we learned today. Not only did we learn about rocket fuel, but we also learned about Newton's laws of motion. So we've got Newton's first law of motion, which is an object at rest will remain at rest until an outside force acts upon it. And then an object in motion will remain in motion until an outside force acts upon it. So your rocket, it just sat there, right? Until we created our fuel options and put it inside the rocket. And then the reaction, that the combination of those fuel items, it created a force. And that force kept our rocket moving until the force ran out, right? And then gravity acted upon it and pulled it back down, got it moving back down towards our table, down towards Earth. And the table actually stopped its movement. So we've got a lot of different forces working, don't we? Excellent. Another one of Newton's laws that we saw working in here was Newton's third law of motion, which is every action has an equal and opposite reaction. So the action of that gas trying to escape, the gas that was created by your Alka-Seltzer and liquid. So that gas, when it ran out of room in there and it wanted to get out, and it popped that lid off, so the fuel came out downwards and the rocket went upwards. So every action has an equal and opposite reaction. Newton's third law of motion. Well, guys, fantastic job. I had so much fun learning with you today. And until I see you next time, race you to the moon.